So what is the formula we learned? Whenever a current carrying, this is very important. Now we are doing numericals based on this. So this is a magnetic field. When a current carrying wire is placed in a magnetic field, okay, of length L. So there is a force acting on this current carrying wire. That force ka formula in vector form also we have to learn. Tell me in vector form, what is the formula? I into
B
L
cross L.
cross B. L cross B. B is a magnetic field. L is the length of the wire. Okay, and I is the current carrying wire. When I open the cross product, what is the formula? IBL or IBL sine theta. Theta is angle between what? Theta is
L
angle
and
between
length
L
and
and B. Length vector should be taken along the current direction only. Length and magnetic field ka angle is theta. This angle. Okay. So whenever they're given vector form, use this one. Whenever they're given in scalar form, normally IBL sine theta is the force. So different. This is the principle of motor also, right? When you on the switch, the fan may, when you on the switch, the fans are rotating. Why? Because of this force acting on the coil. Okay, this is already current carrying coil. There's a coil is here. When you on the switch, current start flowing in the coil. When the current start flowing in the coil, there is a force between them. Because of that force, it start rotating fan. Okay. Chalo. Now iska numericals करेंगे. I into L cross B. IBL sin theta is a formula we have to learn. Okay. Chalo. देखो. A wire of length L carries a current I along x-axis. Okay. X-axis में is x-axis. This is y-axis. एक wire है. It is along the x-axis. Length L carries a current I. Carries a current I along x-axis. A magnetic field exists which is given in, देखो they given vector form. So magnetic field is how much they given? B naught I cap plus B naught J cap plus B naught K cap. The magnetic field, matlab it is there in all directions, I, J, K. The magnitude of force acting on the wire. Since there is a magnetic field and since I place current carrying wire, definitely there is a force. Force kitna is asking. Force formula we know that. I into L
B naught
cross
K
P.
cap minus B
Huh?
naught minus B naught K cap into minus B naught J cap minus B naught K cap into I.
L nahi hai. L is also there, right? So what you can tell me? L vector kitna liya?
X axis.
So it is L I cap
Yes.
cross ये वाला B naught I cap plus B naught J cap plus B naught K cap. Now tell me what is I cross I?
0.
Okay. I cross J.
Cross K.
So B naught L K cap. Okay. Plus I cross K.
J.
J. No wrong.
Minus J.
Minus J. So it is minus. Khatam. B naught L. Therefore, F is equal to B naught L I common ले तो K cap minus J cap. This is a force acting on the current carrying wire. Chalo, next. Find the force on a wire. Magnetic field is inverse. Length is like this, and the I is flowing. Definitely, there is a force. Force is how much?
IBL by 2.
I will be 2, which is wrong. Okay. Why? Because whatever the angle वो नहीं लेने का. So what is the formula I told you? F is equal to IBL sin theta. Theta is angle between what?
I. Okay.
Theta is angle between
L and B.
L and B. देखो, L is like this in XY plane and B is in Z axis. So what is the angle between them? Length and magnetic field? 90. So force is IBL. They wanted they'll give that table के. So theta, I said people रहेगा answer wrong करेगा बोल के. Okay. चलो. So IBL is the answer. So always याद रखो theta is the angle between L and B. A bit. Next. चलो. on a smooth inclined plane at 30 degrees with the horizontal. Okay, एक inclined plane है 30 degrees with the horizontal. Okay, a current carrying metallic rod is placed parallel to the horizontal rod. Okay, एक rod is a horizontal से parallelly एक rod बना है, एक rod है. Okay, the plane is मतलब plane ऐसा, this is the plane means ऐसा, this is a rod, ऐसा rod. Okay, the plane is located in uniform magnetic field 0.15 Tesla in the vertical direction. So magnetic field is in the vertical direction. How much that is? 0.15 Tesla. Okay. For what values of current can the rod remain stationary? The mass per unit length is 0.3 kgs per meter. Unit length means 1 meter. Okay. You tell me, in inclined plane, when I put a rod, which force is acting this direction? Which force is acting in this direction?
Gravitation.
Gradient force. I told you in Newton's laws of motion also. mg we should not take downwards. mg ka components we should take. What is the along the component?
mg
mg?
cos
No.
sin
mg sin theta.
theta.
And this direction to mg cos theta. Okay. Now because of mg sin theta, only suppose only one force is acting, definitely the rod will be coming downwards. Okay. But आपको what is the condition? It should remain stationary. Okay. So current carrying rod detailing, right? तो current किस तरफ होगा? Tell me. Current किस तरफ होगा? देखो मान लो the current is like this. Into the board current is going. मान लो into the board. Now apply check the force. Tell me. Right hand palm rule use करो. देखो magnetic field is ऊपर. Current is like this. Force is like this. Right? Magnetic field. Current is into the board and force is like this. So this is angle F. And देखो inclined plane horizontal is theta 30 degrees and inclined plane horizontal is 30 degrees. Now what is the component of force along this direction? F cos, wherever theta is there उस तरफ cos आएगा. F cos 30. That means this force is balancing with this force. Then only the rod will balance. The rod is stationary. Okay. Now equate and try to calculate the force. Now equate. mg sin 30 is equal to F cos 30. F is how much? What is the formula for F?
IBL
Force on a current carrying wire. I B L. Sin theta is how much? Theta is how much? Angle between magnetic field and length.
60.
Magnetic field ऊपर. Length is like this. 60. Why 60?
90 minus 30.
90 minus 60. Yeah.
Minus 90 minus 30.
So angle between length of the wire and the see, length of the wire should be taken along the current direction. Okay. Current direction is going into the page, into the 90. So IBL sin 90 into cos 30. F के जगह में I put. Now equate and try to find F. Now find the, what is saying to find? The value of current चाहिए, I चाहिए. I find
2 by root 3 L.
2 by root 3.
Yes.
करो करके बोलो. आंसर चेक कर रहे क्या कर रहे?
Doing
मत करो. mg by 2 is equal to IBL cos 30 is root 3 by 2. Now mass per unit. L is how much you took? L is how much? Something you're telling a formula answer.
L also getting because variable.
L per unit length, mass per unit length I'm talking. Mass m by L value only they given as 0.3. So m by L value के जगह में 0.3 लगाने.
Two by root 3.
2
2 by root 3.
no not 2 by 3. m by l के जगह में 0.3 into 10/2 is equal to I into 0.15 into root 3.
20/3.
20/3. So therefore I is equal to 20/3 amperes current is flowing. मतलब if it flows 20/3 amperes, then only the balance हो जाएगा distance. Okay. चलो. Now till now we learned about one conductor. Now I am using different shape का conductors I am using. उसका क्या होगा we'll see. Okay. Now find the force on a AB wire. The current is like this. Okay. The current is coming like this and going like this. Okay. I want to find the force on AB wire, BC wire and complete wire के ऊपर force चाहिए. Okay. Now you think there is no the L shape wala, only one rod, AB rod is there. Is placed magnetic field. Force find करो. Force on AB. What is formula? IBL. Sine angle is how much? Length and magnetic field. 90 degrees. So sin 90. Now use and find the value of force on AB. L is 3 meters. I the given is I only. In terms of variables we'll get.
Oh, 3 IB.
3 IB. And direction देखो. Which direction? Magnetic field is inverse. Length is right side. Current is like this side. And force is downwards. So it is F1 or FAB. So similarly, BC find करो.
4 IB.
Okay. 4 IB. Okay. Direction?
Left side.
Magnetic field. The current is going upwards and the force is left side. Force on BC. Okay. Now tell me what is the complete wire के ऊपर कितना force लग रहा है?
5 IB.
5/B ना?
5 IB.
Why?
Resultant.
देखो. Downwards is 3 IB. 3 IB. And left side how much you got? 4 IB. The resultant direction is 5 IB. So for this के लिए, for the complete wire के लिए, you have to use one shortcut. Okay. Shortcut क्या है? The formula which you are writing, F is equal to I into L cross B. L you should take as a displacement length. Displacement length. देखो, the shortest distance from initial position and final position. देखो, here current is entering and current is leaving, right? This distance को we call as displacement length. Tell me displacement length कितना है? 3, 4 and 5, right? Right? Now that means indirectly, instead of whenever they ask complete wire, there is now only one wire. Current is going like this. Okay. And length is 5. And now what is the force acting on this formula? IBL. 5IBL, right? देखो 5IBL. Okay, sir, मैं I into always take the displacement length and solve 5IB. So answer is 5IB is the answer for complete wire. And displacement length मालूम है ना? Shortest distance from initial position, final position, join the line. That is nothing but displacement length. करो. A current Ln is bent in the form of this shape. 10 amperes current is flowing. And magnetic field is 5 Tesla. Perpendicular to the paper outwards. So magnetic field is coming outwards. Find the force acting on a complete wire.
500.
Hmm?
500.
Wrong. 500. See, we should not take individual, right? What is the condition to displacement length, right? Displacement length is shortest distance from initial position and final position we are joining. So if I find length, this one finished. A length कितना होगा देखो? 4. This is 3. This will be
5 and 5.
5. This is also 5. So 10. Matlab indirectly what is happening? There is a magnetic field and the wire is 10 meters ka length hai. 10 centimeters ka length hai. Can you explain like this? Tell me now, what is the formula? Now F is equal to IBL sin 90, right? Because magnetic field length, right? तो सबसे करो I is मालूम है, I is 10 ampere, B मालूम है and L मालूम है. कितना?
500. 10 into 10 into
10 centimeters means you can't convert it in meters.
10 centimeters.
Right.
5.
Yes. So if I substitute 10 into magnetic field is how much they given? 5 into 10 by 100. क्या तो? It is 5 newtons. This is force acting on the wire. So थोड़ा displacement length find करने वाला है. चलो. Find the resultant magnetic field of PQ. एक current carrying wire है, semicircular है, उसका radius is R and magnetic field is inverse. पूरा plane में inverse है. He's saying what is the force acting on this PQ. So कितना try करो?
Should we take a tangent or?
No, tangent नहीं है. This is a different shape wire, right? We should take the displacement length. Shortest distance from initial position to final position. मतलब indirectly.
So the angle.
This angle is how much?
The angle, can we take a tangent or?
No. What tangent? The magnetic field is coming inwards, right? This is a length. So what is the angle?
90.
खत्म. IBL sin 90. Now L is how much? Length wire is how much in terms of radius में?
2R.
2R. खत्म. So F is equal to IB into 2R. So force direction बोलो. Now tell me. Force direction. Magnetic field is inwards. Current is going right side and force is upwards. So this is upwards. So always consider the displacement length. Then it is easy for you. Otherwise complicated हो जाएगा calculation के लिए. Covered? Writing up. Find the force on a circular loop as shown. इसका displacement length कितना है? What is the displacement length? Instead of taking this one, we will take a displacement length. Shortest distance from initial position and final position. What is the?
0.
0. So force acting on the wire is 0. Because there is no displacement length. कोई भी point ले लो, initial position, final position is same. So there is no displacement length. The force acting on the wire is 0. मतलब when I put there is no force acting on that wire. Okay. No is answer. 0. Why? 0 तो भाई 0 नहीं है तो भाई.
So 0.
0. Why? 0.
Magnetic field is cancelling.
Huh?
Magnetic field is cancelling.
Why magnetic field is cancelling? कुछ नहीं magnetic field cancelling. दिस इज यूनिफॉर्म मैग्नेटिक फील्ड, नॉन यूनिफॉर्म मैग्नेटिक फील्ड? देखो मैग्नेटिक फील्ड इज ऊपर, राइट साइड, लेफ्ट साइड, दिस साइड, दिस साइड, दिस इज नॉन यूनिफॉर्म, नॉन यूनिफॉर्म। वही बिफोर प्रॉब्लम्स में देखो मैग्नेटिक फील्ड इज यूनिफॉर्म मैग्नेटिक फील्ड, कंप्लीटली इस तरफ सेम जा रहा है। बट इसमें इफ यू सी डायरेक्शन देखो, इफ डायरेक्शन इज चेंजिंग मैग्नेटिक फील्ड इज चेंजिंग। सो डायरेक्शन ऊपर, राइट साइड, लेफ्ट साइड, नीचे, दिस साइड, एवरीथिंग इज चेंजिंग। एट दैट टाइम देयर विल बी ए फोर्स। वो फोर्स कितना है देखो, एंड द फोर्स विल बी डिफरेंट डिफरेंट डायरेक्शन में, डिफरेंट डिफरेंट फोर्स, राइट? सो आपको क्या करने का, I will take a small dl element. See formula, small dl element I am taking in the direction of the current, right? dl element. And magnetic field उस जगह में magnetic field is B. Okay, the small dl element I took here and here. हाँ, उस direction. And current is flowing in the same direction, right? इसमें जा रहा है current. Okay. So now tell me what is the small force acting on that small element, current carrying element? Small force कितना है? I into
I dl
dl cross B.
yes.
Is a small force in that small element में magnetic field is constant बोल के we are assuming in that small element में. Okay, now if I expand I dl b sin angle is how much? Angle between dl vector and magnetic field angle is how much? 90. So small force acting on this is I dl into b. Okay, but direction देखो, tell me direction here. Magnetic field is ऊपर, current is going right side and force is inwards. Next इसका देखो, suppose इधर DL element I took. Tell me. No, magnetic field, इसका magnetic field is right side and current DL element is downwards and force is inwards. So every जगह में inwards होने आ रहा है force. That means total force आने के लिए simply integrate. Addition of all, if the direction is different, again सबका force calculate करना पड़ेगा. All forces are same here. So कितना होगा? F is equal to current is constant, B constant, and what is it? DL पूरा मिल गया तो circumference, right? Addition of length is 2 pi r. So this is answer. And direction is into the page. Direction is into the page. Is all force on a current carrying wire. Is all questions करने का आपको idea आएगा. 2-3 क्लास में हो जाएगा chapter. Done. Okay. Next. I go. Here one current carrying wire is there. This is one current carrying wire. This is one current carrying wire. Magnetic field is inwards into the page. Pura magnetic field is inwards. Okay. He's telling to calculate the magnitude of magnetic force on the frame. Complete frame में मुझे magnetic force चाहिए. Calculate. इस वायर इज ए डिफरेंट शेप, राइट? आपको क्या करना है, डिस्प्लेसमेंट लेने का, राइट? इसका डिस्प्लेसमेंट लेंथ इज इस ओनली, एंड इसका भी इसका इस ओनली, एंड फॉर दिस आल्सो इसका ओनली. सपोज मतलब इफ यू कैन फाइंड ए फोर्स ऑन दिस वायर इनटू 3 करो आ जाएगा. ओके, दैट मींस इनडायरेक्टली you have a magnetic field which is inverse and there is only current carrying wire like this, I A C. Now calculate the force on this wire and then multiply with 3. You'll get the answer.
And IB.
3?
And IB.
Yes. IBL. 3 IB. Okay. Because IBL sin angle मालूम है ना? Angle is 90. Okay. Next. Go. Find the force on a length L wire. Length L wire है. इसमें I2 current is flowing to an infinite current carrying wire. A distance दूर में. Is going to find the What is that? Find the force on the wire. Tell me, because of this current carrying wire, there is a magnetic field here or not?
Yes.
Which direction magnetic field is? Because of this current carrying wire, what is the magnetic field direction? Chahiye?
Towards me.
Huh?
Out of the bridge.
No. Dekho, thumb indicates the direction of current and curled fingers indicate direction of magnetic field. This current carrying, thumb indicates direction of current and curled fingers indicate direction of magnetic field. So magnetic field is inverse.
Yes.
Now you know when our magnetic field is placed, when a current carrying wire is placed inside the magnetic field, definitely there is a force on this wire. Force kitna is asking.
I2LB.
हाई टू एल बी ऐसा लगेगा, बट इधर आपको अंडरस्टैंड होने का दिस टाइप ऑफ क्वेश्चन एग्जाम में पक्का आएगा. ओके, सो हाउ टू फाइंड दिस वन. देखो फ्रॉम हियर टू हियर बैड सी फॉर ए करंट कैरिंग वायर व्हाट इज द मैग्नेटिक फील्ड इन ए इनफाइनाइट वायर की वजह से. बिकॉज ऑफ इनफाइनाइट करंट कैरिंग वायर व्हाट इज द मैग्नेटिक फील्ड एट ए डिस्टेंस ए. टेल मी, we done infinite wire mu naught by 4 pi
I by A into sin theta.
नहीं, that is finite wire. mu naught by 4 pi into 2 इसका करंट करेंगे कितना है I1 by distance is R मान लो A but R मान लो. Okay, now tell me it is inverse relation of distance or not? Inverse relation मतलब as you go away from the wire magnetic field will increase or decrease? Decrease. That means here the force is more. Which direction force check करो अगर magnetic field current and force is upwards. And बाद में when you going away from the wire the force is decreasing.
Yes.
That means this is a non-uniform field for this wire. Non-uniform field. Directly we can, you are telling the formula only for if you consider this one only. ऐसा नहीं है, largest force नहीं चाहिए, total force चाहिए. उसके लिए क्या करने वाला है? This is a non-uniform field है ना, उसके लिए what we do? Integration. तो मैं क्या करूंगा, इधर से x डिस्टेंस पर जाके a small dx element I'm cutting. उसके ऊपर फोर्स df है, small force is df. Okay, always from this way. Then we'll put the limits, we'll get the thing. Okay, now tell me what is the force acting on this that wire, small df force.
I into DL.
I is what? I2, right? I2 into B is B. And
DL.
IB length is how much? L नहीं है ना? dx.
DX.
And angle is how much? Sin. Length and magnetic field is into the page, right? 90, right? This is a small magnetic field. And magnetic field B के जगह में लगाओ. df is equal to I2 B के जगह में mu naught by 4 pi into 2 I1 by how much distance from here to here? X.
X.
That length, because जो भी length लगा रहे हैं उसका length का distance you put into dx. Okay, you got a small force acting on the small wire. Okay, now total force है integrate. So F is equal to mu naught by 4 pi into 2 I1 I2 integral 1 by x dx. 1 by x का integration is
Log X.
log x. So F is equal to mu naught by 4 pi into 2 I1 I2 log x. Integration is from where to where we have to integrate, from where to where. Initial point is from here to here is how much distance? Initial point A. And final point is
A plus L.
A plus L. So A to A plus L. So log x to the base E, A to A plus L. So upper limit minus lower limit. So F is equal to mu naught by 4 pi into 2 I1 I2. Upper limit minus lower limit means log A plus L by A to the base E. समझ आ रहा है? log m minus log n is log m by n. So इस पे log m by n we put. तो ऐसे क्वेश्चन आर देयर. हम लोग सोचेगा यूनिफॉर्म फील्ड है, ऐसा नहीं है, नॉन यूनिफॉर्म फील्ड है. ओके चलो. Now force between two parallel current carrying wires. Force between two parallel current carrying wires. देखो we have a important formula है, इसमें भी क्वेश्चन आएगा. Suppose first wire is here, एक second wire separated by distance d. इसमें current is flowing I1, इसमें current is flowing I2. Okay, they are going in the same direction, right? At that time the force acting between them is attraction force. Whenever same direction attract, so what we say, parallel current attract. Parallel current attract always. Okay, so why it is attracting, we will see. देखो you tell me, because of first wire, what is the direction of magnetic field here? Because of first wire, direction of magnetic field I want. Right hand thumb rule ago and tell me, because of first current carrying wire, what is the magnetic field direction? Right hand thumb rule. Thumb indicates the direction of current and curled fingers indicate direction of magnetic field. So here magnetic field is inverse. Now tell me, because of second wire, what is magnetic field at this point? Outwards, because thumb is a gumo, thumb indicates the direction of current and curled fingers outside. So outside. Okay. Now apply the force direction. एक बार check करो force. Magnetic field is inverse. Current is upper. Force is towards this right, left side, right? Force on 2 due to 1. Now इसका देखो. Magnetic field is upper, coming towards you, and current is going upwards. The force is like this. Force on 1 due to 2. देखो, they are attracting, right? That's why. So whenever two transmission lines, that's why they will keep some distance. If you see in the top poles, three lines will be there, right? Three lines, live, neutral, earth will be there, right? So a तीन phase का भी रहेगा, right? So थोड़ा दूर रहेगा. If you keep less distance में, same current attract हो जाएगा. Okay. So parallel current attract. Can you tell me unparallel current, anti-parallel current क्या होगा? मतलब this is going upwards and this is going down. क्या होगा? Ripple होगा. So लिखो anti-parallel current ripple. Anti-parallel current ripple. So इसके लिए force you can calculate. How to calculate force? Force on a current carrying wire means IBL only. Okay, and because of first current, there is a magnetic field, right? That magnetic field you have to find because of infinite wire, and we have to calculate the force. Okay, try करो. अभी try करो. Force find करो. एक क्वेश्चन का जैसा भी रहेगा, that's why solve करो. I want to find, see both are equal and opposite force. So one force find करो, this force find करो. Force on 2 due to 1. This force find करो, and I'm taking per unit length. I calculate this length is L because ये infinite wire है ना. Infinite wire का we cannot calculate, right? Per unit length we are calculating. इसके ऊपर force कितना calculate करो. And इसके वजह से the magnetic field is inverse. तो solve करो. So what is magnetic field on second wire due to first wire? This is an infinite wire, right? So mu naught by 4 pi into 2 I1 by distance between them is D. A वाला magnetic field उधर है उसके ऊपर. Okay. Now force formula F21 is equal to I is I2 B, length is L, IBL, and angle between them is, देखो length and magnetic field angle is 90, sin 90, right? Now B के जगह में लगाओ, F21 is equal to I2 into mu naught by 4 pi into 2I1 by D times length. Now length को इधर पे करो, F by L लगा रहा हूँ. देखो I am doing like this, F21 is equal to minus F12 is equal to magnitude I'm taking F1 row. See, both magnitudes are equal and opposite, right? Same only, but magnitude same. That's why I'm taking F. So F by L is equal to, formula is mu naught by 4 pi into 2I1 I2 by D. Is the force per unit length is a formula. आपको वेरी इंपॉर्टेंट ये फॉर्मूला कितना, वेन एवर टू पैरेलल करंट कैरिंग वायर्स होगा तो फोर्स पर यूनिट लेंथ इज गिवन एज मच. अगर वो बोलेगा 10 सेंटीमीटर मींस 10 सेंटीमीटर से मल्टीप्लाई करो टू गेट फोर्स एक्टिंग ऑन एवर. सो फोर्स फॉर्मूला बैठ करो, टेल मी व्हाट इज द फॉर्मूला.
mu naught by 4 pi 2 I1 I2 by D.
F by L is equal to, F by L is equal to, copy it. Writing neatly notes, I'll check one day. Proper लिखो. See, this notes only will help you last में. करो. Force acting per unit length. I want F by L value. That formula based on that.
Two into 10 power minus 4.
Units. Force per unit length, right? Newton per meter. Newton per meter. So 2 into 10 power of minus 4 Newton per meter is answer. Formula is mu naught by 4 pi into 2I1 I2 by D. D is 2.5 centimeters, right? Next. देखो क्वेश्चन पढ़ो, अंडरस्टैंड करो and tell. Two wires A and B carrying current I1 I2 as shown in figure. देखो A and B wires से I1 I2. Okay. The separation between them is D. दोनों का वायर का separation is D. A third wire C can be anywhere. देखो C dotted line लगाया. It can be here, it can be here, or it can be outside the B. It can be anywhere. Okay. Carrying current I is kept parallel to them at a distance x from A. Either I can put here, or from either से x distance दूर में उधर. From wire में लगा. Three positions में anywhere I can put. Such that net force acting on it is 0. आपको वो लगाना पड़ेगा सच्चे with that net force acting on it is 0. The possible value of x is C. Tell me now which direction में लगाए तो net force is 0 आएगा. मतलब here we'll see. Okay. Now tell me, suppose मान लो third wire में current is going like this. Okay. A direction fix कर दो. Okay. Now tell me, anti parallel currents क्या होगा? Attractor repel.
And anti-parallel ripples.
Ripples. So ये क्या करेगा? ये इसके ऊपर force on C due to A इस तरफ आ रहा है. अगर वायर बीच में लगाए तो. This one tell me. ये दोनों parallel currents क्या होगा? Attract. So force on C due to B. Whether net force is 0 in this? Net force 0? No. Net force not 0. That means ये नहीं है. मतलब बीच का position नहीं है. Now try for another position. Net force means आपको opposite direction में रहने का force. They are not cancelling. Okay. Then next, if I put here, इधर से x distance दूर में, and current fix कर दो receiver. Tell me now, because of this say anti-parallel क्या होगा? Repel होगा. Force on C due to A. And parallel current क्या होगा? Force on C due to B. Now net force is 0 here. Net force 0 हो सकता है. Okay. Now try करो equate and is telling to find what? The possible values of x is how much? Distance is how much? So आपको क्या करने का, सिंपली नेट फोर्स जीरो मीन्स सिंपली फोर्स ऑन सी ड्यू टू ए इज इक्वल टू फोर्स ऑन सी ड्यू टू बी. कैलकुलेट करो एंड इक्वेट, यू गेट द आंसर. फोर्स फॉर्मूला मालूम है, फोर्स बिटवीन दिस टू वायर. हाँ
minus di2 by i2 plus i1.
करो अच्छे से. So force on C due to A. Tell me, what is the force between two wires? Mu naught by 4 pi into 2 I1. हाँ इसमें करंट I ले लो. हाँ I1 I by
X
हाँ X is equal to इसका
mu naught by 4 pi 2i by 2i into i2 by x plus d.
2I2 I by X plus D. अनो कैंसिल करो. 2 I by X is equal to I2 by X plus D I1. हाँ therefore क्या होगा, X plus D is equal to I2X by I1. So X कॉमन लिया तो 1 minus
minus
I2
d
by
by
I1.
i2 plus i1.
हाँ. So X is equal to minus D I1 by I1 minus I2 is answer. Very important questions करो अच्छे से करो, don't tell answers. इधर भी फोर्स जीरो हो सकते हैं ना, इधर से एक डिस्टेंस दूर में, here also force can be zero,
Yes.
but the answer will be same. If you do that also, answer will be same. Okay. Find the net force on a square coil. This is an infinite wire. 2 centimeters दूर में I put a square coil. इसमें कितना करंट फ्लो है, 1 ampere is flowing in this wire, and the length is 15 centimeters and width is 10 centimeters, and इसमें current is 2 amperes. Force on a square coil. So how to do this one method कर रहे हैं. इस करंट कैरिंग वायर की वजह से मैट फिल इज इनटू द पेज, एंड यूनिफॉर्म मैट फिल नॉन यूनिफॉर्म मैट फिल, नॉन यूनिफॉर्म. ओके, सो फर्स्ट ऑफ ऑल ट्राई टू फाइंड फोर्स इसके ऊपर, इस करंट के ऊपर फोर्स विच डायरेक्शन. मैट फिल इज इनवर्ट्स, करंट इज लाइक द राइट साइड एंड फोर्स इज अपवर्ड्स. सो F1 एंड सिमिलर इसका मैट फिल करंट इस तरह राइट साइड and you are downwards ये वाला. Okay. Now if you see carefully, top and bottom में, if I take a small from here to small element, I'm taking one element, and same distance में one more element I'm taking. So this force and this force is getting cancelled, right? Similarly ऐसा each and every part of the element के ऊपर force is getting cancelled. मतलब ये force we should not count. Only this force and this force we have to count. Whether these two also get cancelled? Because magnetic field is decreasing when you go away from the wire. So that's why आपको net force will be, net force acting on the wire is you can take whichever bigger value minus smaller value you should take. Okay. So which will be bigger, F4 or F2? F4. F4. Why? Because near है ना?
Distance.
So F4 minus F2. Okay. Now try to calculate the force between these two current carrying wires, and that also separately find करो and equate. Subtract करो आ जाएगा. So F4 is mu naught by 4 pi into 2 into I1 I2, 2 into 1 by D. D is 2 centimeters. 2 into 10 power minus 2. 2 to cancel. So 10 power of minus 7. ऊपर गए तो. So F4 is 10 power 2 into 10 power of कितना? Minus. हाँ? Force per unit length we are calculating. ठीक है, force one right? हाँ, into length. Length is how much? इस length का 50 centimeters. 15 into 10 to the power of minus 2. करो, कितना आएगा? So 2 into 10 to the power of minus 7 into 15 into I cancel. So F4 is equal to 30 into 10 to the power of minus 7 newtons. These are force per unit length. We did not force we are calculating. And इसका second one?
4.8 into 10 to the power minus 6.
Final answer, हाँ?
Yes.
कितना?
4.28 into 10 to the power minus 6.
No, wrong. Second force कितना है?
Second force I got 12. Same thing by 12.
No, F2 is force between these two wires. So mu naught by 4 pi into 2 into 2 into 1 by distance between them is how much? 12, right? I think this one is from here to here 12, right?
Yes, I just
Into length is 15 into 10 to the power minus 2. So 2 6 2 3 3 5 15. So F2 is equal to 5 into 10 to the power of minus 7. It don't cancel. 10 to the power minus 7. Newton. Now separate करो. This one is this. So it is net force is, so 30 minus 5 is 25 into 10 to the power of minus 7 newtons. Yeah.
yes.
Distance maybe you took wrong. 2 plus 10, 20, 12 centimeters.
I written single step, so maybe
Yeah. Chalo. Now, sometime whenever this concept comes, they will ask define 1 ampere. What is 1 ampere? According to in terms of this one, 2 parallel current carrying wires separated by distance d. When I can say the current flowing is 1 ampere in both wires. Okay. So that therefore देखो एक बार force per unit length calculate करेंगे. Tell me force per unit length calculate करो. When d is also 1 meter. Mu naught by 4 pi into 2 I1 is 1, I2 is 1 by separated by distance is also 1. So कितना होगा? Force per unit length कितना है? 2 into 10 power of minus 7.
Yes.
Right? Newton per meter. मतलब whenever दो करंट के बीच में force acting this much, then we can say the current flowing is 1 ampere. Okay. So definition कैसे लिखेगा? Current when flows into two infinitely parallel current carrying wires separated by 1 meter distance, then produce a force per unit length is 2 into 10 power of minus 7 per unit meter of length. इतना force act हो रहे तो दो conductors के बीच में, then we can say this is 1 ampere. Exam में भी आएगा. So इधर तक हम लोग करेंगे. Next topic, magnetic movement, and we'll have with 3 topics. Magnetic movement, torque and moving coil galvanometer. अगर वो हो गए तो पूरा चैप्टर डन.